Hello friends, today we will study block diagram algebra. Now in this topic we will study different types of blocks and arrangement and its arithmetic and mathematical calculations, how we can reduce a big block diagram into a small, and so on like this. Starting from the open loop control system, that is also known as open loop control system, in which a control system is represented by a block with its transfer function gs and output as cs, where cs is actually the controlled variable, or it is your output variable, and here c of s represents that it is the Laplace transform of output variable. Okay, where input is defined as rs, where rs is known as reference input, or it is here represented in terms of its Laplace transform, that is Laplace transform of rt is equals to rs. Okay, so the open loop transfer function of this system is equals to gs, where gs is nothing but is the ratio of output divided by input. Please be remember, in all the cases the transfer function means the ratio of output to input. Okay, now if we continue with the next type, that is closed loop control system. Closed loop control system these are also known as control system with feedback or system with feedback. Control system with feedback. Okay, so we can represent this system as like this. That is, we have a block here, that is forward block, and its transfer function is gs. Okay, and this gs is actually the transfer function of forward path transfer function, you can say that. And here this is cs, and in this case we have also included a feedback block whose transfer function is actually hs, and we have taken a signal from this side and connected it in this way such that like this. Okay, and here we have given this output to this side, and here we use a summing box. So in this case this is denoted by plus, minus, and you have connected here a line. So this is your RS, this signal is your ES, this signal is your BS, and this is CS. This is the simplest closed loop control system with feedback, and this symbol may be written, this plus sign may be written outside this. Okay, so this may be minus or this may be plus, like this. So no need to write both these symbols. Now this ES starting from this RS, RS से start करते हैं, तो this is RS is your reference input. Okay, and reference input point lies at this position. Then this is your summing box. ये आपका है summing box. Okay, and ES, क्योंकि समिंग बॉक्स की जो इनपुट्स हैं वो है आपके पास RS माइनस प्लस BS. तो आपके पास दिस इज योर एक्चुएटिंग सिग्नल. ओके, तो एक्चुएटिंग सिग्नल की वैल्यू क्या है? RS माइनस प्लस, बिकॉज यहाँ पे माइनस लिखा हुआ है, मैंने माइनस भी हो सकता है और प्लस भी हो सकता है, तो माइनस प्लस BS. सिमिलरली आपके पास जो CS है, CS इज योर आउटपुट वेरिएबल, and this output variable is given by ES multiply GS. ओके, जो भी आपका इनपुट पे सिग्नल होगा इसको इससे आप मल्टीप्लाई करेंगे. And this is the beauty of your Laplace transform, that we can directly multiply these two signals, because in case of a Laplace transform the convolution is calculated with the help of simple multiplication. Okay, so this HS is the transfer function of feedback path. Okay, GS here now becomes transfer function of forward path, because जो पाथ आपका इनपुट से आउटपुट की तरफ जाएगा, दैट इज फ्रॉम दिस साइड टू दिस साइड, तो दिस इज योर फॉरवर्ड पाथ, एंड ये है फीडबैक पाथ. एंड BS इज योर feedback signal. This BS is actually given by यहाँ से आप निकाल सकते हैं HS की टर्म्स में, because HS is actually output divided by input. Output is BS divided by CS, because at this complete line, the value of this complete line is at any place is actually CS. Okay, so we can say that BS, feedback signal BS, is equals to HS multiply C of S. So if we want to find out the transfer function of this complete block diagram, transfer function of closed loop system, which is not shown here, is actually TS and is given by CS divided by RS. Now how can we calculate this? So start calculating in this way, that as you know that this this SCS can be written as here ES multiplied by GS. Okay, so we have to start with this. We know that ES, sorry, C of S is equals to E of S multiply with GS, and if we replace ES, because ES is actually RS minus plus BS multiply GS. Okay, so when we open this, then it becomes R of S minus plus BS dot GS, and if we put the value of BS here, that is here we have to multiply it with GS also. This is RS multiply GS minus plus BS is actually HS multiply CS multiply GS. Okay, if we shift this term towards left hand side, so we will get that is CS, because it is a minus plus sign, so this will change to plus minus CS multiply HS multiply G of S is equals to RS into GS. Okay, so take common part CS from this side, so we will get 1 plus minus HS GS equals to RS GS, or the transfer function TS is equals to CS divided by RS is equals to GS divided by 1 plus GS HS plus minus. Okay, if the sign of this is very important here. Now if, please be remember, because this formula will be regularly used in this subject. Here if the sign is in reverse, plus minus is there, then this will change to minus plus. It means if negative feedback is there, then we have to use positive sign. If positive feedback is there, then you have to use negative sign. Okay, so this is the transfer function of your closed loop control system. Now we have to do some minimization techniques here, that is block diagram reduction. Starting from the basic connections of blocks, the very first is, that is series connection of series connected blocks. Now if two blocks are connected in series, two or more blocks, you can say that, then starting with the simple one, let us suppose we have two blocks here. Suppose this is your first one block and this is your second block, okay, and both are connected by means of some connecting wire, signal path, signal flow wire, and then this output, sorry, like this and this way. And let us suppose these two blocks have their own transfer functions as G1s and G2s. Okay, and this is your reference input and this is your controlled output or output variable. Then what will be the equivalent or its equivalent representation by a single block? Now if we close this block, this system, in a box, then we can represent this system like this, that is CS. Here this is G1s multiply G2s, and here this is RS. This is same as RS. These two are same actually, okay. So we can replace the combination of these two blocks with the single block, that is both the transfer function of both the blocks, that is block 1 and block 2, are multiplied. This is block 1 and block 2. So in this way, if number of blocks are attached in series, then you can say that suppose this is a block, suppose this is another block, suppose this is another block, and here there is a connection like this. So this is like this and this is like this is CS. Then overall transfer function, because here the overall transfer function should not change. Here this is the overall transfer, because the overall transfer function should always be same at both the conditions. Now let us calculate the overall transfer function of first example, example 1 here. In this case, the value at this position will be RS multiply G1s, okay, and at this position this will be equal to RS multiply G1s multiply G2s. Similarly, you can write it in the transfer function here, that is this CS will be RS multiply G1s multiply G2s, okay. So the transfer function will always remain same. So in this way also we can also solve this block, that is G12 G2s G1s G2s and GNS. So net transfer function of this combination will be equal to, net transfer function of this combination will be equal to That is, we have to find out the net transfer function here, and we have to enclose this body as this one, like okay. So this becomes G1s multiply G2s multiply so on up to Gns, and this will be equal to Cs, and this will be equal to Rs. Okay, so there will be no change in the system representation here. You can also represent by a series combination, and series combination can be replaced by a single block. Now next is, that is, takeoff point. In our closed loop system, this point is actually known as your takeoff point. Okay, so takeoff point can be at any place. That is, this takeoff point can be at this position, can be at this position, can be at this position, can be at this position. Anywhere it can exist, and according to the existence of this takeoff point, from where we are taking our signal, that will affect our system. Okay, so we will now study its algebra techniques. Takeoff point. Now in case of takeoff point, we have to take two different conditions. First, takeoff point across a block. Suppose there is a block here, and this block has its transfer function Gs, and here this is Cs, and this is Rs. Okay, so there is a takeoff point here, and we take this point as like this. So what will be the output at this arrow? This will remain same because this contains the same signal throughout this path. Okay, throughout this path the signal will remain same. Now what will happen if we want to move this takeoff point from this position to this position, that is from a block after a block to the before a block position. So what changes we have to make so that this output should not change, that is this output, because we are changing this part. Okay, we are changing this part. So let us take what changes are to be required here, because in this case if we change here this system, because if the takeoff point is shifted here, in this case this takeoff point is shifted, because at this position this will be equal to Rs. Okay, and we need Cs. Cs here is actually Gs multiply Rs. Okay, it means we have to add another block here with the same transfer function across which we are moving our takeoff point. So in this way this will give you again Rs multiply GS and this is equals to CS. That is, these two conditions must be same here. Okay. So movement of a takeoff point from a position after the block to the position before a block requires to add a block with the same transfer function. Okay. Case 2. This is your case 1. And in case 2, suppose we are using in case 2, suppose we want to shift this takeoff point from this position to this position, that is from before a block to the after a block. Now again the condition will remain same, that the output of this takeoff block should not change when we move it from this position to this position. Then in that case, what arrangements are needed? See here. In this case, we need to add a block with 1 by GS transfer function. Okay. Here. So this becomes RS, this becomes CS, this becomes the same takeoff point which is moved from this position to this position. Okay, and in this way this is your RS, this is your GS, this is your CS. So what we have to move, because at this position this is your CS, this is CS is equals to RS multiply GS. What should be the value of this block at this position? Because we need a RS at this position, so we have to divide this function, this input signal, by GS. So it must be 1 by GS. Okay, so this is the necessary condition here. Now second case, that is in case of takeoff point, if we want to move a takeoff point from a position after a summing box to a position before a summing box. Case 3. Let us suppose this is a summing box here and we want to plus minus, this is your RS and this is your CS, and here we have added another signal X1S. So what is the value of CS? And this is your CS. So CS will be RS plus minus X1S. RS plus minus X1S. Now if we want to shift this takeoff point from this position to this position, then what are the necessary changes are required? Just look at this, the scene, that if we want to shift it from this position to this position, the only this line we have to move here. Okay, rest will remain same. So in this case this is CS, and in this case both the outputs should remain same. There should not be change in any of these outputs. when we change it. And if we change it like this way, then because here this is your RS, if we want to have a takeoff point at this position, this is your X1S. Okay, this is only having RS at this position. At this position only RS is having, and here the value is RS plus minus X1S. One output is same, however we should also maintain this output as the previous output. So what are the necessary conditions? We have to add a box here, okay, and we have to add, that is plus minus, with X1S, and this is your, sorry, the arrow should be output side. So this one is again same, this is your RS plus minus X1S. Okay, so we have to add, another summing box here. Now take case 4, sorry, that is, if we want to add a, if we want to move, not add, if we want to move a summing box, takeoff point from this position, okay, this is plus, this is plus minus, this is X1S, and this is R, this is CS, and this is your RS. If we want to move this takeoff point from this position to this position, what are the necessary conditions here? So look at this case, because if we move this takeoff point to this takeoff point, we will get this output, that is RS plus minus X1S, but we need only RS. It means we have to subtract this part from the output. So in this way you can say that the block should be like this, that is, this is plus plus minus, this is X1S, this is RS, this will be CS equals to RS plus minus X1S, and if we shifted this takeoff point, this one, from this side to this side, so we will get another CS, but we need to subtract this part. We have already discussed that this part we have to remove it from, because we need only RS here. So we need to add a box here, summing box with plus sign, and additionally we have to add a signal with minus plus, because this is here plus minus here, there we have to revert the symbols, we have to revert the signal, sorry, its polarity. So we have, this is X1S, and this will give you the same signal, that is RS, because this will cancel this part of the signal. Okay, so this is about takeoff point. Now what about if two blocks are in parallel? This is the last case here, blocks in parallel, that is blocks in parallel. Suppose we are using a summing box here. At this position, okay, and here is the output, that is CS, and here three blocks are added with plus plus plus. This may be minus also, okay. So in this way, this is plus, this is plus, and this is plus. So these are the blocks in parallel with G1S, with G2S, and with G3S. Please do not forget to apply arrow sign so that it will show the direction of flow of signal. And this is your RS. So these three blocks are actually in parallel. So in this case, the output is actually RS multiply G1S, here RS multiply G2S, here RS multiply G3S. So you can write it like this, that is G1S plus G2S plus G3S. Okay, so we can replace this combination by a single block, that is if the three blocks are in parallel, so we can write it like this, we can replace it by this, that is CS. Okay, this is G1S plus G2S plus G3S, and this plus sign is due to the presence of these plus signs, because this is plus, this is plus, this is plus. Here these three are plus signs. If any of the sign is changed, suppose this sign is changed, okay, so this sign is changed from minus plus to minus, then we have to change this sign also. This is to be changed from plus to minus, we have to replace it with the minus sign. Okay, so this is all about block diagram reduction techniques. We have to apply our block diagram reduction techniques in next lecture with an example how can we use these techniques to reduce a big block into a small block. Okay, thank you, thanks for watching this video.